We can see our property vector A given A1, A2, A3, and we have vector B with the components B1, B2, B3. We can see here when A is parallel to B. A is parallel to B. This implies, as we have seen before, B is equal to K times A, scalar value type A. Then their vectors are parallel. We can have another way of looking this one. This is number one, when they are parallel. Number two, we can see here, when they are parallel, then we are having B1 over A1 is equal to B2 over A2 is equal to B3 over A3. I will show you with the help of the example. This is number, I think it's number 4. Then we are having number 5. We are having here A is orthogonal to B. A, B are orthogonal. That's as we have seen before. What do you say? We say A dot B is equal to 0, then they are orthogonal. And number, just here this note 1, instead of this I will say note 1, and this one is note 2. We have already defined it before, note 2. And note 3 is, I want to find the angle between two. So as I mentioned before, my theta is equal to cosine inverse of A dot B over magnitude of A into magnitude of B. I will show you this with the help of examples that we can apply to get the angle between two vectors. Number one, we write here angle. We want to find angle between two vectors. This is my example 2. An example given to us is you want to find the angle between the vector. Find angle between vector A. The vector A is given to me as a component I minus 7j plus 4k. And I have vector B. My vector B is equal to 5i minus k. Here the value component of j will be equal to 0. So solution of this one, I apply the formula with theta is equal to cosine inverse of A dot B over magnitude of A. Find these values and substitute it here. I find A dot B. I use my formula A dot B is equal to A1 B1. That's the 1 into 5. Then we have plus A2 B2 is minus 7 into 0 plus A3 B3 4 into minus 1. So get the result 5 plus 0 minus 4. That's my A dot B. I find the magnitude of A. So what's the magnitude of A? This is the norm of A having root sign. A1 square is 1 square plus A2 square minus 7 whole square plus A3 square plus 4 whole square, and we are getting this is equal to 1 plus 9 plus 49 plus 16, and this is equal to 66. 49 plus 1 is 50. 50 or 16 is 66. Then I find the magnitude of B. What's the magnitude of B? B1 square. So B1 square is equal to 5 whole square, and then B2 square is 0 square plus B3 square is equal to minus 1 square. So that give me here this is equal to root of 25 plus 0 plus 1. We add it, we get here root of 26. So I substitute in my formula, my theta is equal to cosine inverse of we are having here A1 dot B1, we get here this equal to 1 over magnitude of A1, magnitude of A is equal to 66. Here is cosine inverse of 66 into 26. So that's my result I'll get for finding this one, and I can write here my theta. Yeah, I written this already. So it's the idea how we can find the angle between two vectors. Next example, we're having two vectors A and B. I want to show that these are orthogonals. Now we've already seen that when a vector A and B are orthogonal, then the dot product is equal to 0. we'll find their dot product, and if the dot product is 0, then we say A and B are orthogonal. Before I go further, just remind it, the notes for this lecture is given in the description. You can just go there, and in Google Drive you'll get my notes, click it and get the notes. Now obviously you can subscribe it and you can press the bell icon so you can get the other videos also. So here is A dot B, find the dot product. What's for A dot B? A dot B is equal to A1 B1 is 3 into 4, A2 B2 is minus 2 into 5, then A3 B3 is equal to 1 into minus 2. So we add it, multiply them and add them. 12 minus 10 minus 2 is equal to 12 minus 12, and we get this equal to 0. When it's equal to 0, this means the angle between these two is equal to pi by 2. I will say that A is orthogonal to B. So this is the idea, that we use the dot product, and if this value is going to be equal to 0, then we say that these two vectors are orthogonal. Here we can see, find the value, this is equal to 0. So we say is orthogonal to B. In next example, example 4, we want to find the value of C. Value, it can be more than one. We can say value or values of C such that the vector A and B are orthogonal. We see some constant, we can just find the value of that one. So when they are orthogonal, we say A and B are orthogonal. If they are orthogonal, this means we'll get here A dot B equal to 0. This means we find A dot B and put that equal to 0 to find the value of C. We find here A dot B. Our A dot B is A1 B1 is equal to 4, A2 B2 is equal to 44, A3 B3 is equal to minus 3C square. So that gives me here 48 minus 3C square. If they are orthogonal, this implies A dot B is equal to 0, and this implies 48 minus 3C square is equal to 0. I take 3 common, I get 16 minus C square equal to 0. I factorize this one, I get here 4 minus C, 4 plus C, and 4 minus C equal to 0. They are 0 when C is equal to minus 4 and C is equal to 4. So when this is the value of C is equal to 4 or C is equal to minus 4, then we say this vector A is orthogonal to vector B. We got it by using the idea that if they are orthogonal, that means we are having the definition that A dot B will be equal to 0. So we are having the distributive law. We can have first we find 2A and 3C. B is not having change. So there are two ways of doing this one, that we take dot product of 2A and 3C, and then we take dot product of B and 3C minus 3 dot 3C, and then we add it, or we find their sum and take the dot product that one. Both ways the result we say, because this is obeying the distributive law. So I can find here 2A. So my 2A is equal to 2 into my vector minus 2, 3 and 1. I multiply by 2. I get here minus 4, 6 and 2. This is here is my 2A. I find here 3C. So my 3C is equal to, multiply here by 3. 3 into vector C is 1 minus 5, 2 is equal to 3 minus 15 and 6. So now I want to find this value, 2A plus B. My 2A is equal to minus 4, 6 and 2 plus B. What's my B? My B is 7, 4 and 5. This vector 7, 4 and 5. We add them. We get here minus 4 and plus 7 will be 3. I get here 6 plus 4 is 10, and I having here 2 plus 5 is 7. Now I can multiply this with 3C. So I having 2A plus B, one vector, and then dot product with 3C. So my vector 2A plus B is 3, 10 and 7, dot product with vector 3C. This is my 3C. 3 minus 15 and 6. We take the dot product. 3 into 3 is 9. 10 into 15 is 150. Then here is 7 multiplied by 6 is plus 42. So that give me 51 minus 150. The result of this one is a scalar, and that is number 99. So that's the idea, as I told you. We can also, if we want to do it, we can write also this as 2A dot 3c plus 2a plus b, and we have dot 3c, we find it, this value will be also 99. So we can do it by this way, or we can solve it by opening it and taking the dot product, we get the same result.